I was saying if the cow eats a bunch of food, suddenly in the environment there is food present, tryptophan is present, possibly. Once tryptophan becomes present, I don't need to make tryptophan anymore. So it's going to be saving energy to shut the trip operon off. So let's look at how this happens. So again, the operon is on. There's nothing bound to the operator, right? Usually a distance away from the operon itself is a regulatory gene, right? It's usually not, it's not necessarily a part of the operon. It's, again, located some distance away. This one is labeled TRPR. So this just indicates that there's extra DNA here. Imagine, you remember the E. coli DNA is a long jumbled loop, right? So we're somewhere else on the loop now. The regulatory gene. It produces a protein that acts as a repressor for the operon. Now, if the operon is repressible, meaning always on by default but can be turned off, that repressor will be inactive. You can see that this repressor here, right, it looks like it fits in the operator, but it's not the right shape right now. Here's what happens when tryptophan, the amino acid, becomes present. Tryptophan, or some chemical related to it that's present with it, I don't remember exactly off the top of my head, will bind to the repressor, change its shape, the repressor becomes active, joins onto the operator, and now RNA polymerase pathway is blocked. What we do in class with this activity is I give you guys pipe cleaners, and you put beads on it to represent the structural genes of the operon. And then we use a Play-Doh to be a repressor that sticks on right here. And RNA polymerase, which is some other item that we use, like can't move down the pipe cleaner. It's blocked. So now the trip operon's off. So, and the reason is because tryptophan's present, right? So the bacteria starts using tryptophan, using tryptophan, using tryptophan. Eventually, tryptophan is no longer going to be present. It's going to be all used up, right? What happens? Well, the tryptophan that's stuck to the repressor falls off of it. The repressor falls off the operator, and suddenly RNA polymerase is zipping on down the genes of the operon again and making the enzyme that synthesizes tryptophan. Okay? That's a repressible operon. Inducible operons are normally off but can be turned on. Right? A classic example of an inducible operon is the lac operon. Right? The lac operon has 3 functional, or structural, I should say, genes: lac Z, lac Y, lac A. Right? Here's the operator. Here's the promoter region. Right? Now, what does this operon do? This operon makes an enzyme that digests lactose. Do you want an enzyme that digests lactose on all the time? No, that would be a waste of energy. You only want to produce an enzyme that digests lactose when lactose is present. So what happens is the regulatory gene for this, which is, again, located some distance away from the operon, it makes an active repressor. Imagine this little red puzzle piece fitting in the operator right now. The lac operon is off, right? RNA polymerase might bind to the promoter, but it can't zip on down the genes. It cannot transcribe these and make these 3 subunits of this enzyme. What happens when lactose becomes present? Suddenly, we want lactose to be digested. So a molecule found with lactose, allolactose, is the inducer here. Sometimes you see models show that lactose itself is the inducer. Doesn't really matter. When lactose is present, right, that's milk sugar, right, that is that's going to be what induces the operon to turn on. So lactose binds to the repressor. Remember, the repressor is in this, imagine it here, right? The molecule binds, the repressor changes shape and falls off the operon. Suddenly, the operon is on. RNA polymerase can transcribe the genes and make the enzyme that digests lactose. Once lactose is all gone, it's all digested by the enzyme. Well, guess what? This little piece of lactose will be digested too. So as soon as this breaks down and falls off, the repressor goes back to this shape and binds to the operator again, and the lac operon is now off. So what I want you working on today, I'm probably going to post another video about this from someone else that actually has animations, but I want you to try to get this through your head and learn it.